In my video on having fun with Treesitter in Neovim, I briefly showed how to write some Treesitter queries using the Treesitter Playground plugin. In this video, I'm going to show how to actually do that in Lua, and I'll write a simple little Neovim plugin. It's taken me a second to get around to this video because I've been trying to get used to a new keyboard, and that always takes a little bit of time. And I've also been sick all week, and it has absolutely nothing to do with the fact that Zelda Tears of the Kingdom was released this week. But also, real quick, if you've been watching my videos and you like this content, almost 90% of you are not subscribed to my channel, and I'm so close, guys. I just need seven of you. Help a man's dream come true. But anyway, let's take a look at some code. The whole reason I went down this rabbit hole in the first place was to refactor a bunch of JSON schema into a bunch of XOD schemas. And because there isn't a whole lot of information on Treesitter and how to write Treesitter queries, I thought I would go over that just a little bit more. But as a disclaimer, I am not an expert on doing this stuff. I'm just one man who goes and reads some documentation, and that's not meant as a jab at all. That can be genuinely really difficult. But if you come here to the Treesitter website and go under using parsers and then all the way down here to query syntax, this is where most of the stuff is going to be that you'll want to use. So we have these things called fields. You can query negated fields with this little bash symbol. We also have anonymous nodes, which are used probably most of the time. At least I've been using them most of the time. We can capture nodes using this syntax right here. And this is what is called a capture name, and it's written after the nodes, and they start with the @ character. So this is a capture name. There's some other stuff like quantification operators, the ability to group sibling nodes. There's also alternations where we can have these square brackets to match, in this example, either on an identifier and capture that as function, or on a member expression and call that method. And we can also just arbitrarily put a bunch of keywords between square brackets and call that something. In this case, they're just calling that keyword. There's wildcard nodes, anchors. You can either put an anchor before a node, or you can put an anchor after a node, or you can put an anchor in between two nodes. And we have predicates. And predicates is actually pretty important, so I'll include an example showing how to use these things. First, you're going to want to install these two plugins, Neovim Treesitter and Neovim Treesitter Playground, and use whatever package manager you're using. Nowadays, it's either Packer or Lazy, unless you're still clinging on to the old ways with like plug install, or whatever stuff. I don't know. Moving on, Treesitter is actually built into Neovim, assuming you're on one of the recent releases. But Neovim Treesitter gives us some extra stuff that makes working with Treesitter a little easier. And Neovim Treesitter Playground will just make our life easier. To use the playground, you're just going to type :TS playground toggle, and that'll open up this syntax tree over here. And to see all the shortcuts that are available, as long as your cursor is over here in this window, is you just hit question mark and it'll show you all these key bindings. The most important key bindings are going to be O to open up this little query window right here where we can actually write in our queries. Another one is going to be Shift R to update the syntax tree over here. So if I just like delete something, then come over here and hit Shift R, it'll update the syntax tree. Just undo that real quick. Another one that might be useful is A, and that toggles on and off unnamed nodes, where an unnamed node is stuff like this dot or this equal sign. It's stuff that is important to the syntax, but doesn't really give a lot of value within the syntax tree. So if I'm over here looking at my Typescript at this JSON schema, so I actually have a key map for Treesitter Playground, which is a space capital TP. And that opens up this window right here. Then I'll hit O and open up this window right here so I can write some queries. And the way that this works is you create a pair of parentheses, and then within the parentheses, you're going to type in the name of a node. And then if we come up here, all the node names are the ones that are in purple. Obviously, that'll change with your color scheme. But let's say I just want to grab this top node right here, which is a comment, then I'll come down here and stick that in there. And now I have a query that will search for any comment within the entire document over here. And just to demonstrate that, I will come down here and I'll add another comment. Just put in random text, come over here and make sure to hit Shift R to update the syntax tree, and then come down here. And we're going to use a capture name to highlight matches within the code. And remember that just starts with an @ symbol, and then you can call this whatever you want. So I'll call it foo, and I'll move my cursor off and then back on again. And now you can see that it's highlighting all of the matches wherever there's a comment. But I'll get rid of that. Come over here, update my tree again, and let's actually change this comment to an export statement. Next, if we want to query for a node that is a child of this node right here, the export statement, then within these parentheses, we'll create a new set of parentheses and put in some other named node that is a child of this export statement node. In this case, it looks like we only have one choice, which is this lexical declaration. So I'll just grab that guy and stick it right there and create another capture name and call this ASDF. And there you go. Now we have a capture, and we can keep doing this. Next, there's a child node that is a variable declarator, and we can drill even further down, and variable declarator has a couple different named objects. One of these is identifier and another is object. And we could put these capture names on all of this stuff if we wanted to. Like we call that object, and we call this ident, and it'll match on all this stuff. But I recommend you only put the capture names on things that you're actually interested in. Otherwise, this can get a little messy. So just cleaning things up, I got rid of all of those name captures. And let's say that we just want to look for stuff where there's a key that is named type and its value is some string. So we can find any nodes like this one or this one or this one. Well, if we come down here, we can actually get rid of most of this stuff. And if we walk down the tree, we can see that we have a bunch of pairs here, and within the pair, we have a key and value, and the node type for key and value. It looks like the key is always property identifier, but value can be either an array, or it looks like we have an object. Or maybe if we had some other property in here, like ASDF, and this was true, save that, come over here, update the tree, then you can see that this node can also be true. Like it just totally depends on what the value is. But we're only interested in nodes where the property identifier is type and the value is some string. So we can come over here and we'll just write pair. And I'll call this pair. And now we can see that it's matching on every single pair that is within our code. So let's narrow this down a little bit. So within pair, we're going to have, so first we're going to accidentally quit out of Neovim, and then open Treesitter back up, come over here, open up this thing, rewrite our entire query. So we have pair, which I guess really wasn't that long, but so we have pair, and then as a child of pair, we're going to have a property identifier. So I'll just grab that, stick it in there, and I'm just going to call this prop. And here's where we can use one of those predicates, which is going to be the eq predicate for equal, and we want to see where prop is equal to type. And that is matching, so far so good. And let's say that we only want to find places where type is equal to number. Then we'll come over here and add another child node of this pair object, the outer pair object. And within here, this is going to be a string. And we want this string to equal number. And if I hover over this, it does not match. And the reason for that is because this node right here includes number plus the quotes surrounding number. So we could do this one of two ways. Either grab all this stuff right here and then say that is it. Are you kidding? What is happening? I use Neovim almost every day, all day for work. I'm constantly in Neovim, and this never happens to me. It's just because I'm recording. So let's try this again, and this time I'm going to try not to quit out of Neovim. Usually it's the opposite problem. Okay, I think this is where we were, so I'm going to grab this stuff right here, and then as a child of string, we have a string fragment all the way down here. So I'll type in string fragment and then paste back in this part of our query, and this time it should match, and it matches. So that's one way we could do it. Another way that we could do this is just undoing all that stuff. And because the single quotes are part of this node, we can just add those single quotes here into the capture. So use round enter word quotes. And now that, sure enough, matches. Doing it this way is maybe a little easier, but the query would change depending on whether you're using single quotes or double quotes. Okay, but how do we actually take this stuff and write Treesitter queries that we can use within Lua? Well, first of all, I have this key map where if I have some kind of variable, like we'll say foo equals bar, and I do space ZL, then it'll create this console.log and print out foo. But the key map is pretty simple, and there's some edge cases that I wish it could handle. For example, when I'm inside a function like this, and I'm on the return statement, I mean, I guess the variable declaration is only one line away, so I just do that, but you know, often there's a whole bunch of other stuff in this function, and I might not know exactly where this something is declared, or maybe I'm doing something to this some variable and I want to print out what the value is right before I return it from the function. Then if I use my key map, then it'll create the console.log statement, but it happens after the return statement. And what I really would like it to do would to happen just before the return statement. But if my cursor is on the variable as it's declared, then I do want it to happen after the variable. And another place where my key map doesn't really work is if I'm inside an object like this. So let's say that I want to print out what this properties thing is. If I do space ZL, then it obviously puts the console.log statement in a not very helpful place. So where I really want it is down here. And what would also be nice is if this said schema.properties like that. And there's a bunch of different edge cases like this. Just for this video, I'm going to focus on solving this one though, where I want to use my little key map inside of an object and have it print out just below the object and properly capture the parent object so that I'm doing something like schema.properties instead of just properties. So I'm going to do this kind of a lazy way, but I'm just going to create a new folder. I'm going to call it Lua, and I will call this thing logme.lua. And then within this file, just to make sure that this thing works, I'm going to type, we'll just do print hello. I'm going to create a new key map so that I can run this file whenever I use that key map. So I'm going to type lua and vim.keymap.set, and I want this to run in normal mode. And the key binding that I'm going to do that I've just been used to and been using is my leader key, comma, comma, or space, comma, comma. And then the command I want to run is lua file. And my current working directory, lua logme.lua with a carriage return. And now if I hit space, comma, comma, we should see it print out hello. And it did not because I forgot that. Okay, now if I do space, comma, comma, it says hello. And if I change this to hello world and do space, comma, comma, now it says hello world. So we're correctly reloading this file. So I'm going to start by saying local ts for treesitter equals vim.treesitter. And we also need to pull in something from nvim treesitter. And that's going to be this parsers object. So when we have Treesitter Playground open and we have this syntax tree right here, we basically want to load this syntax tree into our Lua code right here. And the way that we're going to do that is first we're going to get our parser, and then from the parser we can get the syntax tree. And finally from the tree we can get the root node, where the root node is just the node that's the parent of the entire syntax tree. And we also need to know what the language is for the current buffer, because even though I'm writing this with Typescript in mind, I really want this plugin to be able to work with any language. And just to test things out as we're going along, I'm going to create some helper functions. So first I'm going to print out this root, and we'll also print out lang. And then I'll hit my keyboard shortcut, and we see that we get this user data one thing and Lua. And this user data one thing is what a node looks like when it's printed out using vim.inspect. So the other helper function that I'm going to create is this one. So this t function is going to be like printing, but for printing a node. I don't know why I went with t, but that's just what I'm using. But we'll say ts treesitter dot get node text, and then pass in the node and the buffer number, which is just going to be 0 to reference the current buffer. And then I'll come down here and change this to troot, and then we should see it print out the entire file. And there you go. We see the entire file getting printed out. But let's take a look real quick at our code right here and see what kind of query we're going to need. So I'll open up Treesitter Playground again and open up this thing so that we can write a query. And we know that we're going to have some kind of pair. And the thing that we are interested in is the property identifier. So that's like one of these things. We have the pair and then the property identifier. So our query is going to be pair, and then we'll have key, that's just the field name, and property identifier. But that's also only part of the piece, because the other thing that I want to know is not only what is this key right here, but what is its parent, such as schema. So if we come up here, we're going to see a variable declarator. So I guess we're going to want that guy. And then within our variable, we're going to have this object. And then within the object, we'll have the pair. So we know that our query is going to look something like this, but we are going to need to create at least one capture name. And I'll just call this variable for now. And then I will copy that, come back over here and paste it in here. And this is going to be our query string. All right, and then how do we use this thing? Well, I'll get rid of that stuff. And then I'm going to say local query equals ts.query.parse, and then we need to pass in the language, which we already have, and then our query string. And this returns a query. So within this object, we have either iter captures or we have iter matches. And I actually don't really understand when you would want to use one over the other, but I've just been using iter matches, and that seems to work pretty good for me. So I will say for matches in query iter matches, and then we need to pass in the node, which is just going to be the root, and our buffer number, which we're just going to use 0. And then inside this for loop, matches is going to be a table that is a list of nodes. And this list of nodes corresponds to the different named captures that you have in your query. So right now we only have one named capture, which is this variable guy right here. And so matches should only have one element in it. But let's say that we came here and we wanted to also capture this outer object. We'll just call that like object, and maybe also the property identifier. And that part we actually are interested in. So we'll call this prop. Then by adding those 2 extra named captures, we have 3 different named captures within this query string. So down here in matches, matches is going to have 3 different elements in it. And the order that the matches appear in is the same order that we declare them in here. So matches 1, because Lua is a 1-indexed language, which drives me crazy. I honestly don't like Lua. Maybe in my next video, I'll show how to do this in Rust. Ooh. But anyway, matches 1 is going to be this prop, matches 2 would be object, and matches 3 would be variable. And let's show that in action. So I will iterate over our matches. And this match right here is going to be a Treesitter node, and that's why I'm using the T function to print this out instead of the P function. So if I use my key map and run this in this file, it probably won't work. I'm pretty sure it won't work. Well, I guess let's try it. And it does not work. And that's because inside Lua, we're using an invalid node type, because these node types right here, like property identifier, pair, object, variable, declarator, those are specific to the Treesitter parser for whatever language you're working with. But if I come over here to foo.ts and then run that, then it works. And we see all this stuff just getting printed out. So if we only wanted to print out this property capture right here, then we know that that should be the first match in our matches table. So we'll just say prop equals matches 1, get rid of that, and we'll say t prop, and come back over here, and there you go. We can see that it printed out title, description, required, type, and properties. But I just realized I'm getting a little ahead of myself, because I don't want to query the entire tree. I really want to figure out where is my cursor currently, and then figure out what the nodes are around my cursor. And that way, if my cursor is over properties and I do space ZL, then what that should do is first look and see that, oh, my cursor is inside of an object. So I want to not only grab this properties, but also this schema thing right here. So I guess the question we really need to ask is my cursor currently over a property identifier node? So this is going to really simplify this query, but we're just going to take all this and go like that and do that. And then instead of having the root be the node that we're working with, I guess first of all, let's create a new function. We'll call it logme, and this is going to take in a node, and the type of this is going to be TSNode, and that's kind of nice because now we get some IntelliSense right here. But we'll grab all this stuff right here and put it inside our function, and instead of our root, this is going to be the node. And if you hear crying and banging on the floor, my kids are awake. Anyway, let's get the current node, and for that we can just do ts.get node. If we look at the documentation here, it says that it returns the smallest named node at the given position. So let's actually print this out just to see what happens. And that seems to have worked. If I come right here, what if we come right here? And yeah, so that's printing out some stuff, calling this function and printing out whatever node our cursor is currently on top of. So if I come over here, let's try the same thing. And that just gives us schema. What if I come right here? That gives me the entire object. If I try it right here, then it just gives me title. Okay, so this looks like it's working. So now we'll call logme with the current node, and I'm actually just gonna clean this up a little bit. We'll just come right over here and put this in line. Okay, so just clean that up a little bit. And I think I just realized that I might actually want iter captures here. So yeah, let's try iter captures. I'll come back over here and run that key binding and nothing happens. What if I go here? Okay, so that worked. What if we see what the type of the node is? So we can figure that out by going node and type, and we want to print this out, of course. Come back over here and run that, and it's an export statement right there. Great. What about if we're on title? It's a property identifier. So we're getting the right node. So maybe we should check if the node that we're over, if it's a property identifier, try to get its parent, which should be a pair. I think we should be able to do node and parent. Yep. Okay, so what if we do node parent? Come over here and run that, and it looks like we had some matches, so that was good. So I think the thing that we want to do is if our cursor is over a property identifier, we want to capture that node and then just walk up the tree, getting the pair node that is the parent of the property identifier. That's going to be like this guy right here, and then keep walking up the tree until we get to an object, and keep going up the tree again until we get to a variable declarator. And this strategy should still work even if we're like inside of a nested object. So we have a property identifier, walk up the tree to a pair, walk up the tree to an object, walk up the tree to another pair. So if we walk up the tree, we need to check, is the parent a pair? Is it an object, or is it a variable declarator? Okay, so I'll make another function and call it walk up tree, or maybe just walk. We'll just call it walk. Maybe traverse. I know. Get parents. Perfect. Now I want to get some nice little IntelliSense there, so we will call this, actually this will be child instead of node. And I also want to carry the results with us, so we'll just call this results. And this is going to be a table or an array of nodes. And we'll say that the way that this works is we first have the child and then the parent and grandparent and so on and so forth. Basically, the smallest node will appear first. So we'll get the type of the node, which is going to be child and type. And there's 3 different conditions that we need to check. And I guess the first one is going to be kind of like the base case. So we'll say if type equals property identifier, then do something. And if type equals pair, then we'll do something else. And if type equals object, then we will do yet another thing. Okay, so if our child node is a property identifier, then what does that mean? If it's a property identifier, then we want to add that. We want to add, for instance, like this latitude. If we're on latitude, then we want to add this node to our results array. And then we want to find its parent, which is going to be this guy. So this property identifier is going to be an immediate child of this pair node, but then we want to get the parent of the pair node, which is this object, but we don't want this object, we want this property identifier. And then that looks like a recursive process right there. So if we have a property identifier, go up to the pair node, that is the parent, and then go up to the object, which is the parent of the parent, and then go up to the next parent, which is another pair, so that we can grab this property identifier. Although we'd actually probably skip that part and get just the previous sibling of this object. That would probably be easier. And I just realized that we might not need this stuff, but I'll leave it there just in case. Anyways, let's get the parent of this thing. So we'll say local parent equals child parent, and then we should know that the type of the parent is going to be a pair. So I'm just going to assert right here that the type of the parent is pair. And if it's not, then I just want it to fail so that I can figure out how to fix it later. So if we are right here, then the parent node should now be this pair node right here. So we need to get the next parent, the parent of the parent. So I'll just say parent equals parent, and then I'm going to assert that parent's type is now object. And then we should be able to get this property identifier right here by getting the parents, the current parent's previous sibling. And we can just say local sib equals parent prev sibling, although we want the previous named sibling, not just the previous sibling, because the previous named sibling could be something like this colon, which we don't want. We don't want a colon. We only want the named sibling, which should be this property identifier. So let's just print out what this sibling thing right here is and get this get parents thing. And we'll put that right there. Come over here and see what happens. And it looks like it worked. At least it kind of worked. We have properties and latitude 3 times. Interesting. So we'll also make our results array right here. So we'll call this our prop nodes. And the first element in the prop nodes table or array, whatever you want to call this, is going to be our first child node. So I'll just pass in prop nodes right there. And then in here, we will say table.insert results and sib. Then why not, let's iterate over this thing. It'll be a node, and inside our prop nodes, and we'll just print out what the node is. Come back over here and run it, and we get a bunch of different results. Okay, interesting. What if we also say P and just print off some lines right there? And okay, so it looks like it's actually working. Although it is printing out a bunch of different stuff more than just what our cursor is currently over. And that's because we're passing in the parent node and running this query on the parent node. Maybe we actually don't want to do it quite like this. You know what I'm realizing? I'm realizing I don't even think we need a query. If I just get rid of that and I guess still grab this, put that right there so we can print off our nodes. We'll come over here and run it. And yeah, okay, so we don't even need to actually run the Treesitter query, but I showed you how to do it, so now you know. But anyways, we want this thing to be recursive. So we have our sibling node right here. This thing should, we'll add another assert thing right here. Say sibs type should be another property identifier. Then we'll insert that into our results table, and then we want to go up the tree again. So I'll say return get parents, and this time we're going to pass in sibling, and we'll also include our little results array. And this means we also want to check if our type is equal to, need to remind myself, our variable declarator. So we'll come over here and add that in. And if it is, then we want to grab this name right here. Actually, just kidding. I lied again. I'm actually like figuring this out as I go along. So welcome along to the ride. So let's get rid of this, and I think we can actually get rid of all this stuff as well. I'm just gonna add another assertion here and say type equals property identifier, because that should always be true when we call this get parents function. But down here, this thing, sibling, its type can either be property identifier, or if it's just identifier, then I'm going to assume that we're at the variable declarator, and we can just stop right there. All right, so if sibtype equals property identifier, then we'll do this stuff right here. We'll insert the sibling into the results table and then call getParents recursively. Otherwise, if sibtype equals identifier, then we should be at the variable declaration. And in that case, we can just insert this sibling. So I guess either way, we're going to insert the sibling. And otherwise, I guess we're actually not going to do anything. So we can just get rid of that. Sweet. Let's see what happens. Come over here and hit the key binding. And it looks like it works. We get latitude, properties, and schema. And if my cursor is over type, then we should see it print out type, latitude, properties, and then schema. And it does. So awesome. It looks like this thing is working. And yep. Okay. Awesome. So now we basically just need to take that array, or that table, and create a new console.log statement from those nodes. We're almost there. Okay, so getting rid of all that stuff, get rid of that stuff. And now we just need a string. And the string is going to be console.log. And then right here, I think I actually probably want to go in reverse order so that it prints out the variable name followed by all of the different nested object names. How do you reverse a table in Lua? Table.reverse? ChatGPT. Okay, ChatGPT says that there is no built-in function to reverse a table in Lua. So I'm just going to copy this function that it gave me, and I hope it works. We'll, of course, make this a local function. And then come down here and put that right there. And hopefully this works. I guess we'll see. Get rid of that. Let's just, I guess, run this and see what happens. And it looks like it works. Or I guess instead of using this reverse function, we actually just probably come over here and insert the node after we call getParents. Although I guess probably don't need to add that return statement right there. And then get rid of that. Let's see if this works. So over here, run that. We get type, schema, properties, latitude. Schema should be first. Oh, I guess I was adding in the child node twice. Oops. So we'll come here. We see schema, properties, latitude, but not type because we never add it. So we'll just say table insert. I don't know. This is probably really messy, but whatever. I like to follow the philosophy of make it work and then make it better. So I'm just trying to make it work right now. But anyways, now if we run this, we see awesome schema, properties, latitude, type. And that is the correct order that we wanted to see it in. So now if we come right here, we should be able to do s equals s dot dot. And we need to get the node text. And this is kind of nice because with the node text, we don't have to worry about parentheses or quotes or anything like that. Well, I guess there's a case where we would, but I'm not going to worry about it for this video and probably any other video, if I'm being honest. But let's see, we should be able to just do ts.getNodeText, use that again, and pass in the node and the buffer number. Yes, the buffer number. And then let's see what happens if we print out our text, although I guess we do want a dot in there. So add our dot and let's see what happens. And so far so good, except I have a dot, it's dot schema. We just want schema dot. Wait, isn't there a join? We can do some kind of join. So I guess we'll do a local node texts. That feels a little weird in my mouth, but we'll just go for it. We'll say node texts. Oh, just kidding. We'll say table.insert node texts and then ts.get node text with our node and 0 for the buffer number. And then we'll say s equals s with table.join concat. Table.concat. I get confused anyways, table.concat and then our node texts and just a dot. And let's see if that works. So far, so good. We got schema.properties.latitude.type. Perfect. Except what I want is also to print out the name of the thing that I'm console.logging. So we need to do this table.concat twice. All right, so now I'm going to do console.log, and then I'm a single quote guy, so we'll have a single quote right there. I guess I'll also say text, just so that I can do this table.concat once, and then we'll say text, and then our single quote. I guess actually I want a semicolon in there, and then concatenate that again with text, and then we need to close this thing off with just another closing parenthesis. And let's see how that looks. And it's looking pretty good to me. So the last thing that we need to do is actually write this out to the buffer. So for this part, we want to be able to have that console.log statement show up right here on line 20, just after the object. So if we come over here, we can see that we have our identifier, and then above that is the variable declarator. And that node covers the entire object. And this node right here also covers the entire object. So what we really want to get is either these values right here. This tells us the line number that the object ends on, or that the node spans. So it ends on line 18. And this says right here that it ends on line 19, but over here it looks like this stuff is probably 0 indexed. So the first line would be line 0, and then the last line would be line 18. That makes sense. So because we'll already have a reference to this identifier node right here, I think it probably makes most sense just to grab its parent. That might be the easiest. Actually, either way would be easy. We'll go with the parent though. So I'm going to say local last equals our prop nodes. No, not last, first equals prop nodes, and 1, we just want to get the first element, and this is going to be the variable declarator. No, this is going to be the identifier of the variable declarator, so we want to get its parent, and that should be the variable declarator. So we'll just say local declarator equals first parent, and that should work just fine. I will give this a type annotation though. Call this a table with an integer and TSNode. Sorry, my sick voice is barely hanging on here, but we're almost done. So we have our declarator. So what we need to get is the line number where this node ends. And we can get that with just local stop is equal to declarator end. And this is just going to be an integer. And in this case, if we're looking at this file, it should be the number 18, which refers to this line right here that my cursor is currently on. And now we can just use the Neovim APIs to insert our text onto, I guess, the line after. So it would be whatever end is plus 1. So I'll actually just add that on here. So plus 1. So we should be able to just do vim.api.mvim buff set something, set text, set lines. I think we'll use set lines right here. And this is going to take a buffer number, start and end, and take an option saying if we should use strict indexing. And strict indexing, I think, just means that if the index is out of bounds, if strict indexing is true, then it'll throw an error. If it's false, then it'll just won't do anything, I guess. And then the last parameter will be the replacement text, which is our variable right here, s. Okay, so the buffer number, I already forgot what the parameters are. So buffer number, and then our start index, which is going to actually be stop. And then the stop index, which is going to be stop plus 1. And then I'm going to set this to false just in case. I don't know. I think setting it to false seems to just work better for me. Yeah, but going on, our replacement text is actually, I believe this needs to be a table. Yes, so this needs to be an array of strings. We only have one thing, so we'll just pass in s. And this should work. I don't know. I guess we'll find out real quick. So come right here, and let's say that we want to use it on, I don't know, minimum. So I'll hit my key map and see what happens. And it worked. Oh my gosh, that actually worked. What happens if we do properties? That did not work. I mean, it did, but it overwrote the stuff that was already there. So, okay, that's not perfectly ideal. So maybe what we actually need over here is just a new line character. Let's see if that works. So come over here, get rid of that. Oh, nope. Okay, that did not like that. Forgot you can't use new line characters in here. So just kidding. Maybe we'll just add another empty string. And okay, that seemed to be fine, seemed to be happy. Just have some auto formatting on there, but now let's try it right here. And so close. So I think what we need to do is probably get the text of the line that we're replacing so that we can add it back in. So come right here and say local curline equals vim.api.mvim get line, get current, no, not get current line, buff, mvim buff get lines, and buffer number, start and end. So buffer number is going to be 0 and start is going to be stop. You know, that's a little confusing, but it is what it is. And then we'll do stop +1 and false. And let's go ahead and print this out just to see what we're looking at. So hit that and it says console.log. Okay, so it looks like it's printing out the correct line, this one right here. And let's just add some text. We'll just throw that in there. And then no matter where I am in the buffer, it should print off that line. Oh, but that didn't work because my cursor needs to be over a node that is of type property identifier. So try that again and awesome. Okay, so it looks like it's working. And it also looks like it's a table. So we don't want the table, we just want that one line. So we'll just grab the first element and call it good. And then we'll comment this back out and put in, actually, do we want to, yeah, okay, we'll leave that in there. And then we'll just say curline. So now we have our replacement array, which is going to be the first element, which is the console.log statement, and just a blank line, just to give us some extra space. And then the current line that we are overwriting and need to add back in. So let's come back over here and try it again. And okay, that looks good. We'll try it right here. And that also looks good. I think, boys and girls, we may have done it. I don't know. I think I'm going to call this good. Guess we'll come over here and try it out in another file. So let's just do this. And that did not work. Oh, that's because we are in a return statement. Oh, goodness gracious. Okay, so let's open up our Treesitter tree thing right here and come down to this. Oh, this was, I guess, the other use case that I was talking about. So in this, if our statement block, or I guess if we have a parent node that is a return statement, then we'd actually want to put the console.log statement above it. But this video is already super long, and so maybe I'll just turn this into a plugin and let other people use it. I'll make it open source and let you guys do it, because now you know how to do stuff with Treesitter, right? But I'm going to call this good. I still feel sick. I feel like crap. My voice is dying. Like this video, subscribe, and hopefully I'll see you in the next one.